Examples. Welcome back. Today we're going to talk about examples. We're continuation from the last class. Last class we already found out expression for the electric field at point A from source charge capital Q. So that is how large the electric field this is going to be. In today's task, and I promise you after this lecture, and you should learn how to do the calculations for a variety of these charges. The example which we're going to go through it is quite complicated. Let me show you what it looks like. So this is example 22.3.15 and problem number 4. It says that there are 4 point charges located along the x-axis at 1 centimeter, 5, 8, 14 centimeters. What we're looking for, we want to find the electric field at point x equals 1 centimeter, given q equals 4.2 nanocoulombs. So we need to write this down, how large that is. And these problems is kind of a tricky in some sense because it does entails a lot of details. So the problem like this, I normally prefer to write down these charges, label them, repeat them almost identically. So here I'm going to show you really detailed, and I plan to have 2 different separate videos to show you. So let's get started. So I normally use a ruler like this. So here's my ruler. I want to draw an x-axis. You can follow my example here. So I draw a positive x-axis, and so that is what we're looking for, the x-axis. And now we need to put another few charges here. And first of all, we need to put charge Q3. It's positive charge. Q2 is positive charge. Did you see Q2 is a positive charge? Q1 is a negative, so I need to put a negative sign here. I normally prefer to put a negative sign above, so then there is no overlap with the x-axis. Do not get confused. Let me rewrite them on the top. So now we have one more charge, which is negative Q. Did you see here? We have a negative Q here. So just put over here. Now I number them. So first, let's call it Q1. Second, call it Q2. And third one called Q3. And Q4. Forgive me, my Q is like this. I know most of you write Q like this. That's what I was taught, so no way to change it easily. Okay, so let's look at how large each of these charges that is. Did you see we were given negative 2q, so therefore my q1 equals negative 2q, but q itself is equals 4.2 nanocoulombs, so that's what I have. So what I need to do, I just write this down here, 4.2 nanocoulombs, and I convert to the SI unit immediately. When nano is just 10 to the negative 9, so that's what I wrote down. So I could plug it in immediately. Yeah, that should be easy. Just 2 times 4.2 times 10 to negative 9 coulombs. And you can do the rest of these quite easily. So, but all I need to do is just write Q2. Q2 just simply Q. And that's just 4.2 times 10 to negative 9 coulombs. What about Q3? Q3 is 3Q, so therefore just 3 times 4.2. You can find what that is. Q4, and that is the negative Q, so you can see a negative Q. So then I have just put a negative 4.2 times 10 negative 9 coulombs. Usually in our physics major class, we typically do not write them out, but regularly that's easier, so then you don't need to repeat in 4.2 times 10 to the 9 all the time. But it's just up to you. So far so good. So we wrote down the sign and also write down these charges. And the next step, which we're going to write, is the coordinates, because each of these points, the coordinates are different. So what I do for the x1, which is position for the q1, is 1 centimeter. So I'm going to just 1 centimeter. I normally prefer to convert them to SI unit right away, so then I do not get confused later on. Q3 should be 8 centimeters, 0.08 meter. Q4 is 14 centimeter. Okay, so that's what we have. And now let me tell you what's the common mistake. Common mistake. When students found out, okay, I have these positions, and then what they did was just simply, hey, here's a position. I just plug it in. That's all I needed, right? Just plug it in. I get everything. I have K Coulomb constant, which is no, and Q is also given, so I can find the electric field. And the short answer is wrong. So the common mistake is that directly use x coordinates to find the E field. That's a common mistake. What we learned here, this particular R is the distance between where the source charge locates and where the field point is situated. What that means, what we're looking for, correct one should be the distance between the charge, whichever the charge you are interested in, and the field point. So you need to find out where is the point that we are looking for. So if you read this problem again and you notice that we're looking for electric field at x equals 1 centimeter. So that is where the field point is. So this guy is called field point. In other words, E parenthesis x equals 1 centimeter. And this is where the field point is. Okay, so this is where you're looking for the field point. If you do not understand this, you need to stop now. You need to ask questions. Okay, we are not going to directly plug in the x1, x2, x3, x4 into the equation. No. What we're looking for the distance between the source charge and the field point. To be more precise, just x equals 1, how large that is. I want to head off this common mistake immediately. And we'll talk about this in the next video. How do we systematically do the calculation for the distance?